So in Unison, there are no dependency conflicts, and the diamond dependency problem does not exist. And it's for a really interesting reason, which I'm going to talk through in this video. But first, what are we talking about? So you may have found yourself in the situation where you are going to upgrade one of your project's dependencies and you encounter issues with dependency conflicts. So just as a really simple example, suppose your project depends on the base library version 2.3.1 and the JSON library version 1.2.2. And maybe a new version of the JSON library comes out and it's got some bug fix or a new feature that you want, and you decide you want to upgrade. Great. Except there's a problem because maybe the version of base that JSON uses is actually different than the one you have installed. It could be different in either direction. It could be that it is wanting to use an older version of base, and that may be no good for you. You can't downgrade the version of base because the newer version of base might have some feature or bug fix that your project needs right now. Or it could be the other direction where it depends on a later version of base, and for whatever reason, you don't want to upgrade your project to the newer version of base. Or maybe you're okay with doing that, but just not right now. Like maybe that's going to entail a bunch of work, and you actually just wanted this one quick thing from the JSON library so you can get back to what you were doing. This little conflict is kind of a best case scenario because at least we control our project, and so we can decide whether to upgrade or downgrade the version of base. But if conflicts like this occur in a transitive dependency, it can be even worse because you have to sort of wait around for the maintainer of that project to cut a new release that maybe bumps a dependency. And they're going to just do that on their timetable, not necessarily on your timetable. It can sometimes feel like pulling on a thread, and the whole sweater starts to unravel. Often the tooling around this is terrible, and so you might not even know that there's no way that the upgrade can succeed until you're like halfway through a chain of like 10 dependencies, trying to get things, new releases cut and so forth. And it's the kind of thing that can just ruin your day, where you're just trying to get some work done, get a bug fix in, or make use of a new feature, and instead you are off on this yak shaving exercise, and your whole day is gone. Okay, so Unison makes all that go away. It's literally not even a possibility, and it's for a really interesting reason. So we need to first understand, why do these conflicts even occur in the first place? And there is a fundamental reason, which you probably don't even think about, which is that all versions of a library are competing for the same names. Okay? So base version 2.3.1 and base version 3.0.0 are competing for the same names. Why is that? So when you are coding and making use of the base library or the JSON library, you're not typing version numbers in your code, right? You are just typing, the names of the symbols from that library. And so because you're not specifying version numbers in your code, you can only have one version of the library installed. Because when you refer to a symbol like, in this case, json.try_from_text, which attempts to parse some JSON from text, you're not saying what the version number is, right? You're just saying, hey, here's the symbol. And so as a result, you can't have multiple versions of the JSON library installed. That doesn't work. Okay, so you might say well, hey, why don't we just make it? I mean, I can sort of conceptually imagine a system where you prefix a version number onto the symbol name, and so that you could, refer to, instead of json.try_from_text, you'd say some version specifier, and then json.try_from_text. Conceptually, this makes sense, except that it would be hugely inconvenient, and so nobody does it. So why is it inconvenient? It's because traditional languages store programs as text. And so if you're storing the programs as text, then you do not want to be, modifying all that text every time you upgrade a library dependency. So you can imagine how that would play out. You would go to like upgrade your, I don't know, the JSON library, and then you have this like massive textual diff. And then when you go to merge that, it generates all these merge conflicts. And in addition to making the code look terrible. And so anyway, it would just be a disaster. And so nobody does that. Okay, but in Unison, we get to do something different. Because the code is not stored as text, because it is stored as its abstract syntax tree, where the all of the names have actually been resolved to the hashes that uniquely reference specific definitions, then we basically don't need to worry about this. So I'm going to show how this plays out in Unison. So anyway, so here's just like a little sample project, just some sample code here. I've got some JSON text. It's just like a big old text literal. And then I have this silly definition parsed example, which is just trying to parse the text, okay? And it'll either return an error or it will return the actual JSON AST, which you might then do further decoding of to convert that to business objects, whatever. Okay, so if we go ahead and view parsed example, you can see here it is. Here is parsed example. It's calling try from text, and it's mentioning JSON parse error and JSON. If we go ahead and say names of, say, JSON, you can see that this JSON type, it has a hash, and that hash is actually what is stored in the syntax tree. So in the type signature, as we store it in Unison, does not contain the name JSON. Instead, it just contains this hash. And then when you view the code, we pick the latest name for that hash and show it. Also, if we wanted to edit this definition and dump it back into the Scratch file, we do the same sort of thing. You can see this hash actually has multiple names. So JSON 1.3.4 has the type JSON, and it has that hash. And also this Avro library that we're depending on uses the JSON library as a transitive dependency. Notice it's a different version of the JSON library. It's 1.2.3 instead of 1.3.4. That's totally fine. So, it's a transitive dependency that wants to use a different version of JSON. No problem. The JSON type is the same in both. And so actually we do not even need to specify which version we're getting JSON from, because if we just say JSON, it's unambiguous what hash it's referring to. And that's the key thing. Okay. So, so far so good, but now let's see what happens if we install an old version of JSON. I'm going to take, 0.2.2, and this is just like, when is this from? This is from last year. I'm going to try installing this. Yeah, sorry, I'm not sure why that command got cut off, but this was I just did a lib.install of Unison JSON releases 0.2.2. Okay, so now if we ls in our lib directory, you can see, okay, now we've got these two versions of JSON installed. Different versions of JSON, different versions of the same library, completely fine. There's no problems here. But now you'll notice something interesting. When we look at the code of parsed example, now you'll see that it's rendering that parse error type a bit differently. So it's rendering it with a fully qualified name that includes that version number of 1.3.4. And so if we actually just say names parse error, let's do names JSON.parse error. You can see that the 0.2.2, the much older version of JSON, actually had a different parse error type. I believe what changed since then is we added some better diagnostic information. So when a parse error fails, you get better information in newer versions of the JSON library. And so Yeah, so it's perfectly fine. Like if we have some other code where we want to use, I don't know, the old version of the JSON library, we can still do that. It's just that because both of these JSON versions are just installed as direct dependencies, we will, if we're referring to a type that is different, like parse error between the two versions, we will actually have to disambiguate with the version number. So all this is to say that you can install multiple versions of libraries, no problem, and there's really no conflict. The only thing, it just sometimes might get unwieldy if you have like 10 versions of a library installed in your project. But there's no issue with like, oh, you installed version 3 of the Avro library and it wants to use an older version of the JSON library. That's generally no problem. And so we just kind of make these dependency problems go away. You can just kind of focus on writing the code. You can install and upgrade dependencies super easily, and it's all good.